In this video, we're going to solve 2007 Form A question 3. So it says the functions f and g are differentiable for all real numbers and g is strictly increasing. The table above gives values of the functions and their first derivatives at selected values of x. The function h is given by h of x equals fg of x minus 6. So this seems like it's a composite. Explain why there must be a value r for 1 is between r, which is less than 3, such that h of r equals -5. Okay, so this seems like we're going to have to do IVT, so let's write this down. H of x equals f g of x minus 6. So h of 1 is going to equal f g of 1 minus 6. So what's g of 1? G of 1 is 2. So we have f of 2 minus 6. F of 2 is 9. 9 minus 6. So that's 3. That's h of 1. Now we got to do h of 3. H of 3 would be fg of 3 minus 6. So g of 3 is 4. So now we have f of 4 minus 6. Now what's f of 4? -1 minus 6, so that's -7. So now we have the numbers between 3 to -7. So yes, according to IVT, since this function is continuous, there is a value r that will equal -7. Okay, part B, explain why there must be a value c for 1 is less than c, which is less than 3, such that h prime of c equals -5. So that seems like it's going to use MVT. So now what we have to do over here is we know h of 1 equals 3. H of 3 equals -7. So now we could do h of 3 minus h of 1 equals 3 minus 1. So now we have -7 minus -3, right? -7 minus -3, minus 3 actually, all over 2 equals -10 over 2, which is -5. So yes, this is true because it is continuous and it is differentiable. Yes, there is a value r or hc, since it's talking about c, that will equal -5 according to MVT, since this function is continuous and differentiable. Okay, part C. Let me erase this part over here so I have room to work. Okay, that's better. Part C says, let w be the function given by w of x equals 1 to g of x f of t dt. Find the value of w prime of 3. Okay, so that's pretty easy. So w of x equals, let me write that down, 1 to g of x f of t dt. Now I want to know what w prime of t is. Let's just write w prime of x. So w prime of x would equal fg of x times the derivative of g prime of x. This is the fundamental theorem of calculus. You got part 2, I believe. You take this, you plug it in, then you have to take the derivative of this. So if you want to find w prime of 3, that's going to equal fg of 3 times g prime of 3. So what's g of 3? G of 3, let me go down. G of 3 is 4, so we have f of 4 times what's g prime of 3? G prime of 3 is 2. So now what's f of 4? F of 4 is negative 1 times 2. So this thing has to equal negative 2. Okay, part D. Let me erase this piece so I have room to do D. So part D says, if the inverse of g is the inverse function of g, write an equation for a line tangent to the graph of y equals g negative 1 of x. So we need a point and we need a slope. So we have x equals 2. Well, what we have to realize over here is inverse means x and y change and y and x change, right? So what's going to give us 2? So if you look at the graph, we have g of 1 equals 2. So the inverse of 2 equals 1. You're basically working off of this. Okay, now we need to find the slope. So if we take the derivative, we're going to have to use a formula. So g inverse of 2, the derivative of this, is going to equal 1 over g prime, g to the negative 1 of 2, and this is a composite. So now what we have to do is we have to look at our table and we have to see what's g prime of 2. We already said that's going to be 1 according to this. So we have 1 over the derivative of 1. So what's the derivative of g prime of 1? Well, that's 5, so it's 1 over 5. So now we have the point, we have the slope. So now we could say y minus 1 equals 1/5 x minus 2. And I hope this video helped. Until next time.